Okay, good morning, guys. Assalamu alaikum. Welcome back to Inspire Teens, grade 11 mathematics, where in today's lesson, we'll be continuing with functions, okay, where we left off last week. So, just to sort of recap, okay, we discussed functions, okay, we discussed straight line, okay, we talked about the straight line equation. All there needs to be discussed about the straight line equation. We discussed gradient, y-intercept, okay? Then we discussed, importantly, vertical lines and horizontal lines, okay? They come up often, and we have to understand how they work, okay? And we have to understand the equations of these lines. Those are also important, okay? Transformations we'll get back to. Then we discussed the parabola equation, okay? We discussed standard form, turning point form, and root form, okay? And along with root form, we discussed the axis of symmetry. We discussed how the axis of symmetry is the x turning point coordinate, okay? And we discussed the equation of the axis of symmetry, which is also important, all right? So all of these things with respect to parabola graph, we discussed, and it's important to understand in standard form, how do you get turning point? How do you get x-intercept, y-intercept? Right? Sorry, in standard form. In turning point form, how do you get turning point? Because it's obviously in the equation. How do you get x-intercept? How do you get y-intercept? Okay, for both, you make y and x equal to 0. In root form, how do you get x-intercept? How do you get turning points? How do you get y-intercepts? So in the root form, x-intercepts are given in the equation. Okay, so there's two ways to get your turning points, right? You can, if you have your x-intercepts, you can find their midpoint. Okay, because remember that the x turning point is the midpoint of the x-intercepts. Okay, so if you have the x-intercepts, you can find the midpoint. That's going to give you the x coordinate of the turning point. Substitute that into the main equation, and you get the y turning point, right? So yes, and then the axis of symmetry is the x turning point, right? So we discussed that. We discussed the shape of a parabola graph, right? Just what A means. A gives us a smiley face or a sad face, minimum or maximum. Okay, we discussed drawing a graph, determining the shape, x or y intercepts, TPX, TPY. Okay, and yeah, we discussed it in terms of an equation, drawing the graph of a specific parabola equation graph. What we ended on was discussing domain and range. Okay, very important. Domain and range ties into our understanding of intervals, answering interval questions on a graph, which tends to be confusing at times. Okay, so let us continue. We can recap a little bit, and then we'll continue. So we said that firstly, domain. Okay, it's written here twice. We can get rid of it, I guess. Domain. Let's do this. That. The domain, once more, it is y values. So let's maybe do this, I guess. I don't know if that works. Let's do this. Let's do this. The domain, sorry, the range is y values. Okay, so the y values of the graph. What are all the y values of the graph? Can you give us an interval that represents all the y values of the graph, where they start and where they end? Okay, how far up, because it's talking about y values, how far up does the graph go? How far down does the graph go? That explains it as well. Okay, so when we discuss range and we look at this graph, okay, we say how far up does it go? Like, it doesn't matter which part of the graph is going up, like what's the highest y value of this graph? And we'll see that since both are going infinitely upwards, okay, how far up does it go? It goes forever up. It goes to a positive infinity value, okay? And how far down does it go? Does this graph have y values till forever? No, it clearly doesn't, right? Its y values stop here at this point. So a smiley face graph has a minimum, right? How far down does it go? It never goes forever down. It will always go only up until its y turning point coordinate. Okay, so that's how we answer the range question, like understanding what is range. Then we spoke about domain. Domain is x values. Okay, so what are the x values of this graph, right? If you had to give me an interval that represents the starting x value and its ending x value, that would encompass all the x values of this graph. So you're asking yourself, how far left does this graph go and how far right does this graph go? Okay, and if we look at this, right, we ask ourselves, how far left does it go? Just the leftmost value. It doesn't matter which part of the graph is it. Which is the leftmost value? That's going to be obviously the smallest x value. Okay, so yes, how far left does this graph go? You can see that it's going forever up and left, right? It's like an up left diagonal sort of direction. So it's going forever left as well. So it's going to go all the way to a negative infinity value for x. Then you ask yourself, how far right does it go? Same thing on this side. It's going forever up and right. So this graph is essentially going to the right forever, go positive infinity. So it's going to go up until a positive infinity x value. Okay. So yes, that's how we answer domain and range. So when we had to actually answer the question for domain, let's finish up domain because it's simpler. We always say x is an element of for domain and y is an element of for range, because domain is x values, y is range is y values. So we say x is an element of starting value and ending value, finished, right? The square brackets depending on the question. Okay, so the starting value is the most left value. Okay, and the ending value is the most right value. That's always going to be your interval. Okay, and your answer thereafter, once we concluded what the actual domain was of this graph, it's from negative infinity to positive infinity. You cannot include infinity, so that's why we use the circle brackets. Just to revise, square brackets means include something, like the range includes that value that it ends at, and exclude means it excludes that value that it ends with. So for example, what I like to do always is do this 1, 2, 3, 4, 5, 6, 7. It's total 6. So if I had, for example, square bracket, square bracket. In this, all the values it's talking about are all, because it says include 1. So it's 1, 2, 3, 4. Oh, we don't even have to do that. Sorry, let's do this. We don't even have to do it like that. We can just say starting at 1, ending at 6. Okay, so this would be all 1. What did that range comprise of? 1, 2, 3, 4, 5, and 6, because we included 6. All right. What happens if we wanted to do this? If we include 1 but don't include 6, what would this range be? It would be 1, 2, 3, 4, 5. It would end at 5 because we don't include 6. What happens if we don't include 1? If we start from 1 and go to 6, but don't include 1 or 6. So then 1 or 6 not included. So the range here would be 2, 3, 4, 5. Okay, so that's just something to help you with that. Hopefully that makes sense. So yes, include is a square bracket, exclude is a round bracket, and infinity or negative infinity, you never include, you will always exclude with a round bracket. So that's how we got this answer. Another way of writing this is x an element of all real numbers, because from negative infinity to positive infinity. So that's what you can write. X is an element of real numbers. Right, now we are busy with the range. Let's continue discussing the range. Okay, so y is an element of the start value and the end value. Now we're talking about y value. So our start value is the lowest value and our ending value is the highest value. So that's how we came up with y is an element of including negative 5. Negative 5 is the turning point. It's part of the graph. Okay, negative 5 and its highest value, we know that that graph is going to a positive infinity. So positive infinity, we don't include. In interval notation, you can represent it as y is greater than or equal to negative 5. So ranges have set values. Okay, they do for parabola, normal regular parabola functions. Okay, and you can by heart, like I said, some people like to by heart. Okay, it's always this and it's always that type thing. Just like I forget exactly where I mentioned it. Okay, so yes, for range, right? If a is greater than 0, the range of the graph, okay, I'm going to give it in first in interval notation. Sorry, the other one is called inequality. In interval notation, you will say y is an element of, okay, including the yTp, so positive infinity excluding. This is a set answer always. Whatever the yTp is, if you'd like to by heart this, you can. Then we have what happens if it's a sad face. A is less than 0. Then the equation takes the form y is an element of negative infinity being the lowest value and the yTp being the highest value, including. So when A is less than 0, that's a set answer you could remember. In interval notation, when A is greater than 0, sorry, in inequality notation, when A is greater than 0, it should be y is greater than or equal to yTp. And when A is less than 0, it should be y is, so sad face, y is less than or equal to y turning point. So these are set answers for the range that you could give if you'd like to by heart it. Obviously, for any question, because you're giving it in terms of a turning point. Okay, so you can memorize that if you'd like. That's the range and the domain done for the parabola graph, but it should help you understand domain and range for any graph in that case. Okay, so I hope that makes sense. Please, if you guys have any questions, please let me know and I'll answer them immediately. Let's look at this, converting to standard form. So why would you want to convert to standard form? You'll see there are many questions that you would want to actually convert to standard form. For what reason? Perhaps there's a question they want you to solve it. Sometimes they'll tell you, give the equation in the form ax squared plus bx plus c. Then you'd need to know to convert from TP form to root form. Okay, so how do you do that? It's really simple. Okay, converting from turning point form to root form. Converting from turning point form to standard form, you just have to open it up. You have to factor it out. So make this equal to 2 into x plus 2 plus 3, and then FOIL this. So 2 into x squared plus 4x plus 4 plus 3, 2x squared plus 8x plus 8 plus 3 becomes plus 11. And now that I've factored this out, this is basically in standard form. I have A, I have B, I have C. So again, why would you want to do this? So sometimes they might give it to you as ax squared plus bx plus c. And they'll ask you, what is A and B and C? Okay. Or like they'll tell you, prove that that the equation is this or whatever. And the same thing goes for what's this? Root form. Converting from root form to standard form, you factorize out. So y is equal to 2x squared plus 4x minus 2x becomes plus 2x minus 8. And then it becomes y is equal to 2x squared plus 4x minus 16. And that is the standard form version of the equation. So it's really simple, converting from TP form to standard form and from root form to standard form. You're just multiplying it out. So just keep that in mind. Here's a reason why you could potentially do that. There might be one or two other reasons as well. Knowing how to convert them is important. Let's just do this 1 second. Cool, let's move on to the hyperbola graph. So hyperbola, okay. In the general form, y is equal to a over x minus p plus q. So why do we have arrows by p and q? That's a good question. So p is actually, okay, what we call a vertical asymptote, okay, or the x asymptote. I'm just going to put asymptote, okay. And we have another one that tells us that it's opposite sign. We'll discuss what does opposite sign mean in a second. But let's talk about Q, okay? So Q is what we call the horizontal asymptote, or HA stands for horizontal asymptote, or the Y asymptote as well. And as you would have guessed, it uses the same sign. So what are we talking about? Sign, firstly, mathematical sign, positive or negative. That's what we're talking about. And we are comparing it. What do you mean opposite sign? Opposite sign to what? When we talk about the equation and when we talk about the graph, the vertical asymptote in the equation has the opposite sign that it has to the graph and vice versa. Okay, so that's what we mean. Okay, so yes, P gives us the vertical asymptote with the opposite sign. Q gives us the horizontal asymptote with the same sign. This is the standard formula for hyperbola. We have two different possible shapes. When A is greater than 0, we start on the top right and at the bottom left. When A is less than 0, start on the top left. So that's how I like to remember it. Greater than 0, start top right. Then everything else will fall into place. Please note that these are not the axes that I've drawn in here. They're not the X and the Y axis. No, the graph is not always drawn in relation to the X and the Y axis. It's drawn in relation with the vertical and the horizontal asymptote. So when we say top right, we're saying top right of the vertical and horizontal asymptote. Okay, so just keep that in mind. These are not the X and Y axes. Okay. Okay, let's draw this graph. Let's do number 1 and number 2. Then for number 3, oh yeah, we can do number 3 also, it doesn't really matter. Then we'll discuss the axes of symmetry and then draw it in our graph as well. So how do you draw a hyperbola graph? So this is the form it's given in. Okay, so the form it's given in here is draw f of x if f of x is equal to -1 over x minus 2 minus 1. So a few things we have to remember. This guy is the vertical asymptote and it is opposite sign. This guy is the horizontal asymptote, and it's the same sign. Okay, so we know our horizontal asymptotes and our vertical asymptotes. So since our vertical asymptote is actually an x asymptote, it has the equation x is equal to, not -2, 2. Because this is a horizontal asymptote, which is a y asymptote, it has the equation y is equal to, it's a horizontal line. This is a vertical line, this is a horizontal line. Has the equation y is equal to -1, because that's -1, it chooses the same sign. So now we have the equations of the vertical and the horizontal asymptote. We can draw them in, right? That's actually step number 1. Step number 1 is to draw the asymptotes. That's the easiest, right? That's what you want to do. Now that we have the equations of the asymptotes, x is equal to 2 and x is equal to -1, we can simply draw them in. So let's just say, sorry, y is equal to -1. So let's just say x is equal to 2 is somewhere here. So then y is equal to -1 will be somewhere here. All right, and then we draw it in as well. So I've drawn in my asymptotes, right? 3 marks, because you just can get them straight from the equation if the equation is given. So this has the equation x is equal to 2. This has the equation of y is equal to -1. So asymptotes drawn in. Asymptotes drawn in. Let's look at step number 2. Determine the shape. Determine the shape. So you basically need to look at A. In our case, A is negative. A is always on top, the numerator on top. A is negative, right? So because it's negative, we're going to start on the top left. Okay, but you'll notice we can't just draw it. Maybe this bottom one we can draw because it has no intercepts. So it would look something like that. However, the top one we can't just draw. We need intercepts. So that's we can find easily by making x and y 0, respectively. So let's find the x-intercept by making y 0. So 0 is equal to -1 divided by x minus 2 minus 1, x minus 2 minus 1, 1 is equal to the same thing. So when we solve for this, we actually get x is equal to 1. So the intercept is where x is 1. So where x is 1, we can make an intercept there, somewhere here between the two. Okay, let's find the y-intercept by making x 0. So y is equal to -1 over 0 minus 2 minus 1. And this gives us the y-intercept as -1 over 2. So let's jot it in. -1 over 2 for y would be here. Okay, so now we've gotten our intercepts. Let's see if it'll auto draw through them. No, it won't. Okay, it's fine. We'll just freehand it. It would look something like, doesn't have to be perfect, but just make sure that your line is not touching the asymptotes, but it looks like it's going towards it. Obviously, it's probably not drawn to perfect scale and such. That's why it doesn't look perfect, but it would look something like that, right? And then you'd label this guy 1, and then here is -1 over 2. Okay, so that's the intercept label. So draw asymptotes, determine the shape x and y intercepts, and of course, step 4. Okay, draw the graph, obviously, right? You didn't just do all of that work to not draw the graph. Okay, so once your graph is drawn in, done. But before we move on, we have to discuss one more topic of interest. Okay, and those are known as the axis of symmetry. So we've drawn a hyperbola graph with asymptotes. We've now to determine the shape, number 2. And number 3, we just get x and y intercepts and then we draw it. That's it, right? In the denominator, P is the vertical asymptote, always opposite sign. Q, outside of fraction, is horizontal asymptote and same sign. So that's that. Let's look at the axis of symmetry. So let's look at how they look. Firstly, here's an example of a hyperbola graph. The axis of symmetry, the axis of symmetry for this hyperbola graph, okay, looks something like this. Firstly, they always, so what you'll notice here is very nicely, you can see our vertical asymptote. And here you can see our horizontal asymptote. Okay, and where they intersect, okay, where the vertical and the horizontal asymptotes intersect, that is where the axis of symmetry forms. So we have one going this way, nicely, just like that. Okay, and again, what is an axis of symmetry? It's a mirror image. So even though maybe the drawings won't be perfect, right, because they won't ever look like mirrors, in reality, this would act as a mirror. So if we had to fold it across this line, these two graphs would touch each other perfectly. It's acting as a perfect mirror, right? It's an asymptote. So that's one of the asymptote lines. Sorry, not asymptote. It's a line of symmetry. Okay, it's a symmetry line. So that's why when they would touch each other if we had to fold it across that. Okay, so that's one of the axis of symmetries. The other one actually is again cuts through the intersection point of the two asymptotes, but this time forms like the opposite to the other one, an axis of symmetry that looks like that. Okay, so you'll see these lines are very similar. They have standard equations. These are the standard equations. You have two of them. Y is equal to x plus c and y is equal to negative x plus c. That means that here our gradient is 1 and here our gradient is -1. That's always the case for all the axis of symmetry lines, no matter what type of hyperbola we're dealing with. Okay, no matter what, A is positive or A is negative, it doesn't really matter. This is a set equation for the axis of symmetry with a gradient 1. So it's a straight line equation with a gradient either 1 or negative 1. Okay, so obviously the one with a positive gradient is this guy increasing from left to right. Okay, remember if we put Bob here and he's moving from left to right, he would have to walk up. So this one has a increasing gradient. This would be y is equal to mx plus c, but m is 1, so just x plus c. This is the standard equation. However, if we put Bob over here, you'll see that Bob is most likely going to die as he slides down the slide of terror. And that tells us it's a decreasing function. So its equation is y is equal to negative x because it has the gradient of negative 1. So m is negative 1. So it becomes negative x plus c. It's standard. You can by heart that. You need to by heart it, in fact, in order to solve for it. Now, how do you actually solve? Let's get to this example. So I'm going to firstly draw in my axes of symmetry. They're not going to be perfect, I'll tell you that. But they look something like this. That's the first one. You get 2 of them. One with a positive gradient, one with a negative gradient. Sometimes they'll tell you, give the equation of the positive axis of symmetry, or give the equation of the axis of symmetry with a positive gradient, right? They'll specify. So this is how it looks, right? Again, it's not perfect, but who cares? Kind of looks weird, but it's okay. That's what the axis of symmetry looks like. And this here is y is equal to positive x plus c. And this is y is equal to negative x plus c. Now, how do you solve for these equations? So, of course, when you're solving for an equation, you need gradient and you need an extra point to solve for c. Here we know the gradient of these lines because, like I said, it's constant. It never changes. The gradient is always 1 or negative 1, depending on which one we're working with. So how do you solve for c? You need a coordinate to substitute. As you can see, both of these symmetry lines pass one specific point. That is the intersection point of the asymptotes of the hyperbola graph. Now, the intersection point of the asymptotes has a very simple coordinate. Because it's on the vertical asymptote, its x coordinate is the vertical asymptotes equation. And because it's on the horizontal asymptote, its y coordinate is the horizontal asymptotes equation. So that coordinate is very simple. You just take the x asymptote, y asymptote, gives you the coordinate where they intersect. You can then substitute it in. So we can solve for this guy, for example. We can say y negative 1. So we're subbing in 2 and negative 1 into all of these equations. We can say negative 1 is equal to x plus c. 2 plus c, c is equal to negative 3. So this equation is actually y is equal to x minus 3. Then we can find the equation of the axis of symmetry with a negative gradient by simply substituting the intersection point of the asymptotes. So y is equal to mx plus c, negative 1. Negative 1, why is it doing that? Negative 1 is equal to x, negative x plus c, so negative 2 plus c. Okay, let's write one more step so that we can see it. Okay, this is the y is equal to x plus c, and then we substitute it, right? Wherever we substitute it, I'm going to put brackets, so there and there. So here and here, right? Okay, so now when we solve for c in this case, it becomes negative 1 plus 2, which is 1. So c is equal to 1, if I'm not mistaken. I'm getting different answers from what I used to have. Okay, that's because I changed the values. That's fine. Oh, no, I didn't. This is correct. So here, the equation would be y is equal to negative x mx, negative 1x plus 1. That's the equation of the axis of symmetry, which has a negative gradient. And then the one above is the one that has a positive gradient. Okay, and that's how you solve for them. That's how you solve for the axes of symmetry. It's really simple. You have to remember either y is equal to x plus c or y is equal to negative x plus c, and then solve for c. Okay, because gradient is always going to be 1 or negative 1 for the axis of symmetries. Okay, cool. I hope that makes sense. Finally, let's discuss the domain and range. The domain and range for hyperbola is really simple, and you should by heart this. Okay, x is an element of real numbers, except x is not equal to whatever the vertical asymptote is. Y is an element of, so this is for the range, y is an element of real numbers, and y is not equal to whatever the horizontal asymptote is. That's a standard. It doesn't change. Learn it like that. So let's do it in terms of this. I'm not going to even look at the graph, see how far left, how far right. I'm just going to say domain. X is an element of real numbers. Okay, X is not equal to, now I'm not going to say VA, right? I have to actually substitute whatever the value of the VA is, right? Because X is actually on a hyperbola graph, you'll get X being all the values except the value of the vertical asymptote. In this case, it's 2. So X will never be 2. So X is an element of real numbers, mean X will, you have all X values from positive infinity to negative infinity except 2. And then the range, because 2 is an asymptote and the graph never touches an asymptote. Y is an element of real numbers. However, y is not equal to, I'm not going to write the HA for horizontal asymptote. I have to actually write what the value of it is. And in this case, it's negative 1. So y is not equal to negative 1. It's equal to all the y values, but not negative 1. And that is domain and range for hyperbola with an example done. Right, so it's much easier than parabola. You can just memorize those. All right, let us move on to exponential. So it seems like we're moving at a decent pace. Okay, exponential function. Okay, so exponential function, this is when you have x in your exponent. X is an exponent. Okay, so we have P and Q here again. We have a standard formula, y is equal to A times B to the power of x minus B plus Q, a standard formula. So firstly, let's talk about Q. Q represents what exactly? What color did we use? That color. Q represents, firstly, Q represents a horizontal asymptote, or we also know it as a y asymptote. A y asymptote, and it has the same sign in the equation and same sign in the graph. Okay, so we only have one asymptote in an exponential function, and it is a horizontal asymptote, and it has the same sign. Please note, this is like detached from the B term. This is like on its own. Okay. Yeah, it's not like up there. Don't confuse it. It's on its own. Okay. So yes, that's that. So what is P? P is not a vertical asymptote in this case. P is what we call horizontal shift. So whatever the value of P is, okay, it shifts the graph left or right. Okay, and its opposite sign as well, I'm pretty sure. Just like all x coordinates, its opposite sign. Okay, but it's not an asymptote, it's vertical shifting, or sorry, horizontal shifting of the graph. So it's actually like moving left or right, changing the x value. Okay, and it's opposite sign, meaning if it's a plus, we move left. If it's a minus, we move right. Okay, so that's the exponential function, the equation for it. Let's look at drawing, but before we look at drawing, I have a table here representing the different kinds of exponential functions that we can deal with. Okay, so firstly, there's no vertical asymptote for any of them. Okay, and they all have the standard form y is equal to bx to the power negative bx to the power of, sorry, a times b to the power of x minus p plus q. Okay, they all have the standard formula. So now we're going to discuss the shapes of the exponential functions according to the variables. So for example, if a is greater than 0, we have both of these examples. If a is greater than 0, okay, what does it mean? It means above horizontal asymptote. There's only one asymptote in this one. When a is greater than 0, above horizontal asymptote, and you can see that both of these examples we have here drawn the y-axis along with the x-axis, and the x-axis happens to be the horizontal asymptote also. So in this case, when a is greater than 0, this is above the horizontal asymptote, right? Then we have a difference in b. Here we have b greater than 0. Here we have b, sorry, greater than 1. Here we have it between 1 and 0. Okay, and I'll give you examples of both. So here's an example for this one. Y is equal to 3 to the power of x. Okay, now you might look at this and say, but wait, where is a? Okay, where is a? So what you need to note for exponential, always treat the base, the direct base of the exponent, treat that as b always. So 3, what is b here? 3. So don't think that a doesn't exist or a is 3. A definitely does exist here. A is just 1. A is just 1. So this is 1 times 3 to the power of x. Okay? So a is greater than 0 because a is 1. Okay, it's positive. And b is greater than 1. Yes, b is 3. So when you have a greater than 0 and b greater than 0, it's above the horizontal asymptote. That's that. And when b is greater than 1, that makes it increase. Okay, let's use a different one for this. Now, let's look at the next one. We have a greater than 0. So I'm going to have y is equal to a going to be 1, an invisible 1. So that's going to make it above the horizontal asymptote. B is going to be between 0 and 1. So the example is going to be 1 over 3 to the power of x. 1 over 3 to the power of x. So firstly, a, don't think that a is the 1 over 3. A is invisible. In this case, it doesn't have anything. It's just 1. Okay. So A is 1. So it's above the horizontal asymptote. And B is between 0 and 1, 1/3. That results in a decreasing function. Thus, B being greater than 0, but less than 1 results in a decreasing function. So both of them, A is greater than 0. So they are above the horizontal asymptote. It just happens that this one, the horizontal asymptote is the x-axis, right? But when B is greater than 1, it's increasing. When B is between 0 and 1, it's decreasing. Let's move on now to the bottom, where A is less than 0. A is less than 0. So A is less than 0. In both of them, you can see they're below the horizontal asymptote. So that's another key. A, you work with A. If A is greater than 0, above the horizontal asymptote. When A is less than 0, below the horizontal asymptote. So then we deal with B separately. So here B is greater than 1. When B is greater than 1, it's decreasing. So please deal with A and B separately. So here an example of this is y is equal to negative 3x. So A is what? A is negative 1 times 3. Always treat A differently. Negative 1 times 3 to the power of x. Okay, so that's what A is. So A is negative. A is less than 0. That's why it's below the horizontal asymptote. But at the same time, B, so we don't, you see the sign, a lot of people will look at it and be like, y is equal to negative 3x, then they'll think b is less than 0. That's not the case. That is not the case. A takes that sign, so a is negative 1. And b we deal with separately. So b is positive 3 to the power of x. So b is greater than 1. So you might say, how? B is negative 3. How is it greater than 1? Because a is negative 1 and b is 3. That's how we get negative 3. So b is greater than 1. So that means it's below and decreasing. Then we have b is between 0 and 1. With b being between 0 and 1, we would have an increasing function below. And the example would look like y is equal to negative 1 over 3 to the power of x. Okay, and in this case, let's write it here. A is equal to negative 1 and b is equal to 1 over 3. Okay, so b is not negative, a is negative, and therefore b is 1 over 3, so it's between 0 and 1. It's a fraction, so it's increasing below. So you'll notice that it swaps, right? When b is greater than 1 here, it's increasing. But when it's between 0 and 1 there, it's increasing. When b is between 0 and 1 here, it's decreasing. In order for it to decrease at the bottom, it needs to be greater than 1. Okay. Anything else here? I think that's good for now. So these are the shapes, right? Very important. Just go through this on your own. This confuses some people. Some people, it makes sense to them. Just try and make sense of it on your own. It's not important, but it's just another quick diagram thingy that I drew up to help some people understand if it's still confusing. But yeah, above the asymptote between 0 and 1 increasing, above 1 decreasing, below the asymptote between 0 and negative 1 increasing, and then after that decreasing. So let us draw an example. So they say first step is to draw the asymptote, determine the shape, x and y intercepts. So let's have a look at this. Draw the asymptote. So my asymptote, remember the equation is in the form y is equal to a times b to the power of x plus q. So in this case, here's q. Okay, so q, what is this? This is our horizontal asymptote of same sign. So the horizontal asymptote is negative 2. So it's a horizontal asymptote, which means it's a horizontal line, which looks something like this. Okay, now what's the next step? Determine the shape. So what would the shape depend on? The shape depends on A and B. So here we can see that B is 2 and A is positive 1. Okay, so firstly, A is greater than 0, so it's going to be above. So it's going to be somewhere here above, either increasing or decreasing, but it's above the horizontal asymptote. Number one. Number two, B is not equal to 0, B is equal to 2. B is equal to 2, which is greater than 1. So we have to write it in terms of what we learned. A is greater than 0. B is greater than 1. So when A is greater than 0 and B is greater than 1, we have above and increasing. Above and increasing. Above and increasing would look something like this. But because it's cutting the axis, because it's cutting the axis, we will need to calculate x and y intercepts. So that's easy. X intercept, make y equal to 0, right? So y is equal to 2 to the power of, sorry, I should be making y 0, but x plus 1 minus 2. So 0 is equal to 2 to the power of x plus 1 minus 2. Okay. And yeah, so we take the 2 over. 2 is equal to 2 to the power of x plus 1. Remember, this is 2 to the power of 1. When your bases are the same, you can drop them, and you're left with 1 is equal to x plus 1. Okay. And then you solve for x, you get 0. So the x-intercept is 0. So it cuts the x's at 0. So you see, this graph is already wrong. It needs to cut through 0. And the y-intercept should also be 0 because obviously 0 and 0, the origin, is where the x and the the x and the y axis meet. So if it's touching the x axis at 0, it has to touch the y axis also at 0. So we're expecting 0 as well for this. Make x equal to 0. Y is equal to 2 to the power of x plus 1. So 0 plus 1 plus 2 minus 2. And you'll see 2 to the power of 1 is 2 minus 2 is 0. So we're expecting 0. We got 0. So it crosses through there. Now we can draw it to look somewhat like this. Okay, going forever left and down and forever up and right. Okay, and that's about it. All right, this just means also, we said, what is it? Horizontal shift. So right or left. Yeah. Okay, so this is y is equal to 2 to the power of x plus 1 minus 2. This is the graph for that. Okay, so follow these steps. Determine the asymptote or draw the asymptote, free mark, because you can get that directly from the equation. Determine the shape using A and B and X and Y intercepts. That's substitute X and Y is 0 respectively. Okay, let's do a quick recap table. Excuse me, then we can call it there. Okay, so types of functions. Okay, linear function, the equation is y is equal to mx plus c, or okay, I suppose ax plus q. That doesn't really matter. We can get rid of that. Okay, so y is equal to f of x is equal to mx plus c, straight line shape, little straight line looking like that. Okay, and we have two quadratic functions. So here's the different types of examples and the different forms you can get it in. If you remember, I was telling you, right? You don't have to have b in everyone or c in everyone, right? Main thing is you have your x squared function. So you can have f of x is equal to ax squared, f of x is equal to ax squared plus q. Geez, man, sorry. F of x is equal to ax squared plus bx plus c. F of x is equal to a, right? So this is standard form. This is TP form, and this is root form. Okay, TP form gives you turning points, root form gives you x-intercepts, and a parabola graph looks something like this, like a smiley face or a sad face alternatively. Okay, and yeah, don't forget the square there. Cool. Hyperbolic functions or hyperbola functions, okay, can be in the form y is equal to a over x plus q. So this, in this case, this is like having a over x plus 0 plus q. That didn't change the value. This means that the vertical asymptotes equation is x is equal to 0, which is the y-axis. And obviously this horizontal asymptote is y is equal to whatever the value of q is. Okay, so just keep that in mind. Or it can have this where it has both an x and a y asymptote with its own equation, and that's how a hyperbola function looks, right? Remember that we draw with respect to the x and y asymptotes and not the x and y axis. Exponential function in this form or in that form, right? And we have one asymptote, which is the horizontal asymptote, and it has this type of shape. Okay, cool. So let's call it there. You guys can go through the summary, use it just to revise whenever you need to. And the next time I see you, we shall continue with these more difficult, challenging stuff like maximum distance, vertical distance, roots, and like discriminant, intersection of two graphs, and so on. Okay, cool. So thank you guys so much for joining. I hope you guys have a good rest of your week. I will see you guys next week, and inshallah. Jazakallah khair. Assalamu alaikum.